In this opportunity, we are talking about leveraging and unleveraging beta. When we value a firm, usually we require to calculate WACC, the weighted average cost of capital. WACC depends on several parameters. The debt ratio, which is the value of the debt divided by the value of the firm, market values. The corporate tax rate, TC. The discount rate of debt, RD. The equity ratio, E over V. And the discount rate of equity. The discount rate of equity usually is calculated using the capital asset pricing model, for which we need first to calculate the beta corresponding to this RE. And this beta is a levered beta, a beta which is consistent with the capital structure of the company we are valuing. The levered beta of the firm is often calculated indirectly from time series of stock prices of similar companies. We usually select a number of companies which we feel they are similar to our company, and then what we do is that we take a series of prices of these companies, we calculate the corresponding returns, and then we regress these returns against an index. For instance, the Standard & Poor's 500. And this will yield the levered betas of each corresponding company. Given that each of these companies have different leverages, the only way to aggregate them is by unlevering these betas. So the first step after calculating the levered betas of the comparable companies is to unlever these betas, so that now we have an unlevered beta for each one of these comparable companies. The next step then is to average them out so that we have an average unlevered beta, and then we lever again this beta in accordance with the capital structure of the company that we are valuing. So we first have to unlever the betas, and then we lever the average beta. Say that we call BU the unlevered beta, BE the levered beta, meaning the beta of the equity, and BD, beta D, the beta of the debt. The formula that is normally used to unlevered and levered beta is this formula that we can see now in front of us. Beta U, meaning the unlevered beta, is equal to beta E, meaning levered beta, divided by 1 plus 1 minus TC, multiplied by D over E. What some people don't know is that this is not the right formula. The right formula to levered and unlevered beta is the one which is here in the bottom. In this formula, as you can observe, there is an additional term on top in the numerator, which is the beta of the debt multiplied by 1 minus TC multiplied by D over E. So what the analyst is assuming when he uses the first formula on top is that the beta of the debt is equal to 0. The problem is that sometimes, or most of the time, the analyst does not realize that he's making this assumption that the beta of the debt is 0. The problem that we want to point out in this presentation is that at the same time of levering and unlevering beta in this way, again, assuming that the beta of the debt is 0, practitioners often make RD equal to the firm's market cost of debt. So they use a market cost of debt for RD. However, if you do this, there is an inconsistency in the method that you are using. If the beta of the debt is 0 for levering and unlevering, logically it must also remain 0 for the computation of RD. So if the beta of RD is 0, then RD must be equal to the risk-free rate. Of course, usually we are not satisfied assuming that RD is equal to the risk-free rate. Then, if RD is not equal to the risk-free rate, it means that RD cannot be the risk-free rate, so beta D is not 0. And if beta d is not 0, then we cannot levered and unlevered data, assuming that the beta of the debt is 0. So we should use the full formula, not the reduced formula, in order to levered and unlevered beta, in order to have some consistency. And to do this, we have to assume a beta of the debt which is consistent with the systematic risk of the debt. The firm Berniman, some time ago, published the result of the impact on the unlevered discount rate of several firms when, instead of unlevering the betas, assuming a beta of the debt equals 0, you assume a beta of the debt different from 0. It can be observed that the impact is considerable. So the error that can be made by assuming a beta of the debt equals 0 on the unlevered discount rate for the firm is significant. We usually use published betas. We don't do these regressions on our own, but we just look for the betas in certain publications. The problem is that almost always these levered and unlevered betas that we get from these publications assume that the betas of the debt of the reference firms are 0. And of course, if we are using these betas assuming that the beta of the debt is 0, we might be making an important error. Okay, because there might be cases in which the debt carries significant systematic risk, so that we cannot assume that their betas are 0. And this is the problem that I wanted to point out in this presentation. Thank you.